So hello guys and welcome back with another video. So guys, basically we are back with once again very good questions from the Mathsplorers paid test series, and this question you right now see on screen is a really good question, and something similar based on this came in this year's JEE Advanced. Not exactly similar, like the length of the question I say will be similar. It's a very good question. So, guys, if you want, first, please try this question out once for yourself. I will wait for a few seconds and then I will start off solving this. Okay, so guys, I hope now it's time for us to solve this. So, before solving, let's give a small reading to the question. So, R is the region of points small a comma small b such that for any small a comma small b belonging to all real square, the quartic polynomial p of x is equal to x power 4 minus 2 ax square plus b. Okay. And p of x is equal to 0 has all real roots, and all the roots and critical points of p of x lie within the interval minus 1 to 1. This statement is actually very important. Okay, and if area of the region capital R is alpha by beta, then we have to find the value of alpha plus beta. Now guys, if you still don't understand, like things might be a little bit of confusing here after reading this. Basically what they are trying to tell us is that we have to find out this R region. Okay, we have to find this R region, define it piecewise or whatever it takes it to be. Like if it is a piecewise definition, then we have to define it piecewise, this region capital R. We have to define it, and then we have to find the area of this region, which is your alpha by beta, and after that alpha plus beta or whatever they ask. Okay, so if guys, the first thing is your, if we start off, p of x is given to be just a minute, yeah, p of x is given to be x power 4 minus 2ax square plus of your b. Okay, and there are two things given here. First thing is all roots of p of x are real. This is a good question, so I am writing all the info and after that I am doing it. Another thing is given that all roots and critical points lie in your minus 1 to 1. Now this is something which is very interesting. Why? Because now if we try to differentiate px as p dash x, then this will come out to be equal to 4x cube minus of your 4ax, which is basically nothing but 4x times x square minus a. Okay, so if we set this to be equal to 0, that we generally do to find out your critical points, then you will have x is equal to 0 and plus minus root a. These will be the three critical points, right? Now, like if this has to require, like meet the required conditions that all roots and critical points lie in minus 1 to 1, right? So 0 is obviously meeting, but for root a this will be minus 1 less than equal to, I can write plus minus root a itself only, and less than equal to 1. Now if you square both sides, this will become 0 less than equal to a less than equal to 1, which means a has to be in the interval closed 0 to closed 1. That is the point. Okay, so that's the first step, and this is about the critical points. But now they have also given roots and another condition regarding roots, that roots are real also. So let's move on to that. So what I will do is the quadratic equation, like it's a actually I guess a biquadratic equation, but I will convert it into a quadratic equation. X power 4 minus 2ax square plus b is equal to 0. From there I will make this, I will put y as equal to x square, and I will make this y square minus 2ay plus b as equal to 0. Okay. Okay, so after this, first thing is, say if I take the two roots of this to be y1 and y2, say for example, we will manipulate this later, but first thing is that they have given us the roots are your real. So if the roots are real, it means discriminant has to be non-negative, or b square, that is 4a square, minus of your 4ac, that is 4b, will be greater than equal to 0. In other words, if we simplify this, change the sides and all, this will be b less than equal to a square. First thing. Okay. Second thing is they have given that the roots lie in -1 to 1. So if we take the roots say to be some y1 and y2, obviously then x will be nothing but your plus minus root y1 and plus minus root y2. So we will deal with that later on. First, let's work out y1 and y2. Okay, so guys, first thing is that y1, if you apply quadratic formula, it will come out to be nothing but a plus root a square minus b, and y2 will come out to be a minus of root a square minus b. Okay. Okay, so like with this, I just wrote this for your reference. So, but with this or without this, you can write two very definite things, I guess, from this equation, that the sum of roots y1 plus y2 will be 2a, and the product of roots y1 y2 will be b. These two things you can definitely write. Okay, so this is the sum and product. Now basically what they have given us is, because see, if the roots, like they have referred us to x as roots, right, not y as roots. So basically if I take this as say -1 less than equal to your plus minus root yi less than equal to 1, here I is equal to 1 comma 2, I am generalizing it. So if we take this and square both sides, then actually a and yi's interval will come out to be same to same, right? Yi will belong to 0 to 1, and we have also found out that their sum is 2a, right? So guys, now what I am trying to do is, because we have b here, right, we have b here, and we are trying to generalize the region R. Okay, so guys, like here one very basic thing that you need to understand, why I am hunting for the range, domain, everything of A and B. Because our region R that was defined, it is actually all the points A comma B. It is a coordinate, two-dimensional coordinate system where all points are defined as small a comma small b. So if we want that region, then actually we have to find out a definition of this region R, piecewise definition. I guess it will come out to be piecewise definition, such that a comma b, like all the, for this, say, how do I say for a ranged in between this and this, b will be ranged in between this and this, and a ranged in between two values will be b ranged in between corresponding two values, something like that. That will be the perfect definition of R, because that would give us two things. First, it would give us the curve, like it is a region, right? It is a region bound within an area, so that area would be obviously bounded in between two curves. So when we find out this definition, small b will contain the curves, small b will contain the curves, and small a will contain the points. Or rather, when we find out the area, we will integrate. When we find out the area by integration, there the upper and lower limits will be the bounds of a, and the curves which we are taking will be the bounds of b. Okay, I hope this is clear. I have explained in the best way possible. Okay, so guys, proceeding from here, first thing is our a has been defined in between 0 to 1. And now y1 plus y2 is 2a and yi is belonging to 0 to 1. This is the current scenario going on. So guys, I guess we have to define this piecewise. Okay. So guys, to define this piecewise, what I'm doing is, like, we need a logic, right, on what bounds of A we will consider to find out B. So basically, because y1 plus y2 is given out to be 2a, I am taking this 2a as a factor, because y1 and y2 are exactly, I guess, conjugate pairs here. Not complex, like maybe I use the wrong term, not complex, but conjugate pairs. I hope you can understand, right? The form is something like a plus minus root a square minus b. So they are exactly somewhat like conjugate pairs, but not, there is a separate term for that actually. They are not complex, but conjugate pairs. Anyways, so y1 plus y2 is equal to twice a. So I am using twice a as a parameter and then defining the boundary. So guys, first thing is, I will once take 2a greater than equal to 1, and another one I will take 2a less than equal to 1. These will be the two domains on which I will try to find out b. Okay. So 2a less than equal to 1, let's consider it first, because say I can put case number 1 here. 2a less than equal to 1. This thing would imply actually a belonging to 0 to half. Okay. I hope you can understand, because a less, like here this would come out to be a less than equal to half. And now you would take the common area of this with a belonging to 0 to 1. This is already present. You are using this as an extra definition to bound the, like, take a separate boundary and find out the definitions of B. Okay, so if you take this regions and this regions common, then you will find out a belonging to 0 to half. That's the, like, explanation. Okay, so if a is less than equal to half, so a is coming out to be 0 to half. So I guess here y1 and y2, both of them can fit inside your 0 to 1, right? We have already found that out. Still I'm writing out once, can fit inside 0 to 1. So if we refer to B, what can be the minimum product? Like minimum and maximum value will be the bounds, right? So what can be the minimum possible product of B? Minimum possible product, if A is belonging to 0 to half, minimum possible product of B will be when any of them becomes 0. Like if the other one is some large value also, no problem. In the, like, obviously in between 0 to 1, if the other one is a very large value also, very nearing to 1 maybe. But for that, if in the other one, like say y2 is a very large one and y1 is equal to 0, so that is the least value, right? If you tend both of them to very near to 0 but not exactly equal to 0, then also it is not the least value. Least value is 0. So B min comes out to be 0. And if we talk about B max, then your B max will, this is interesting. What will B max come out to be? So guys, here, like, apply your brains once, because y1 and y2 are equal to 2a, right? And a is, like, it's not sort of, what do I say? It's not sort of x or y we are taking here, okay? 2a is a defined value. It is not still, like, we have not still defined the function or piecewise definition of the region R. When we define it, obviously then a comma b will replace x comma y in that coordinate system, but right now it has not. So 2a is a value for us right now, okay? So if we try to maximize this sum for y1 plus y2, then y1 becoming a, y2 becoming a will actually give you the maximum sum. So here the maximum possible product will actually be a square. You can try out any other value you want, you will not get anything greater than a square, okay? That's the maximum value. So basically what we got is, for a belonging to 0 to half, b will belong to 0 to a square. This is the first definition, okay? Okay, so guys, this actually came to my mind, like, still many of you might be having a doubt that why did I put 2a less than equal to 1 and why am I putting 2a greater than equal to 1 in the next bound? So I have a better explanation. Now listen, basically because we have done this right now, you can see a is belonging to 0 to half, okay? So after we do the next one, you will actually observe that half a equal to 0.5 or a equal to half, whatever you say it, this is the point where actually this complete curve will break, okay? Now listen, basically we had a quartic, or you can say a biquadratic polynomial, it is also called a quartic. It's a, like, fourth degree equation, okay? Fourth degree polynomial equation. It's in the form of a quadratic right here because we put y equal to x square. Anyways, whatever. So that particular equation had roots, 4 roots. Now listen, we put 2a less than equal to 1 because in case of 2a less than equal to 1, both the y roots, or rather 4 x roots, they will fit comfortably inside your 0 to 1. Now why? Because if you notice the fashion in which I found out your y1 and y2, then they were conjugate pairs, okay? So in that case, the tightest bound that you can consider is when their sum becomes 1. It can't at all exceed this, because if it exceeds, right, then cases can arise where the discriminant will be less than equal, like the roots will not be real, the roots will become imaginary. If you want, you can try out for yourself, just put some random value and check. You will understand that the roots are actually becoming imaginary because discriminant is coming out to be like here, right here the discriminant is non-negative, but then the discriminant will come out to be less than 0. Cases will arise, okay? So those two conditions which were mentioned above, one condition that roots are real and roots are between 0 to 1, they have actually been done purposely. Purposely, why? So that the roots become real. Okay, and those two conditions are actually telling you all this less than equal to, greater than equal to 1, above, taking those two roots, putting them in bounds, everything. Those two lines are speaking out a lot of things that you need to understand. That is why this question is really good. Okay, if you can analyze those two lines perfectly, then your question is done, because those two lines are literally screaming out a lot of things that you need to understand. They could give you on, they have asked you the area here only. They could give you a lot of things. They could have said, like, check the continuity discontinuity of this point inside. Obviously JEE Advanced won't give that, but they could say, take an interval, a sub interval in between the intervals defined in the function, and then check the continuity discontinuity. They could have given options like this. If they had given those questions, then this would have become a 10 times greater difficult question, because in that case you have to study that like we did about 50% study of the quartic polynomial. Okay, then you would have studied that quartic polynomial in a much more detailed way and then found out. Anyways, like, I gave you an idea of what can happen. Okay, and I hope now this is clear why we put a equals to half will actually be the breaking point. Okay, you can consider it like that. Okay, so guys, up to case 2, where in case 2 we are, I guess, wait, we took the last one to be, I guess, 2a less than equal to 1. So right now we will take 2a greater than equal to 1, which means a greater than equal to half, and taking common with that we will get a belonging to half to 1. Okay, just like the last one, I didn't do anything new. Okay, so first thing is we have to also find out b values here. So we will again take the reference of y1 plus y2 is equal to 2a, and we know y1 y2 was equal to b. Okay, so first thing is, guys, if you notice this sum y1 plus y2 is equal to 2a, it is definitely greater than equal to 1, right? Observe my pen. So if it is greater than equal to 1, at least one of y1 and y2 has to hit 1. If we take the very boundary case, at least one of y1 or y2 has to hit 1. Okay, if we take the boundary case. So in that particular case, say if we let your y1 as equal to 1, then what will be y2? 2a minus 1, right? From the equation. So if this is your 2a minus 1, then actually this is the boundary case for which one? Minimum boundary case. So if this is the minimum boundary case, b minimum will come out to be y1 y2, 1 into 2a minus 1, which is 2a minus 1. Okay, and very fascinating. Like, this is the minimum boundary case, and maximum boundary case is again very same, just like the previous one. Maximum case occurs when either, like, both y1 and y2 are equals to a. So this also becomes equal to a square. That is the beauty of this question actually. If this thing was not equal to a square, then we would have failed in actually calculating this area definitively, because then, like, you can understand, right? Right now, the b interval in the last one ended in a square, and the b interval in this one will, I guess, start from not start from a square. Wait. Okay, not starting and ending. Actually, what is happening is, if you observe 0 to a square and 2a minus 1 to a square, basically there will be an intersection. Okay, and we will find out that intersecting area. Anyways, like, if something of this sort would have happened, say b min came out to be a square and b max came out to be obviously not this, something else, then in that particular case you would have two continuous areas, but the graph would be continuous because that particular point is being contained in both. Okay, it is getting included in both the intervals. But if that was not the case, they were two separate areas, then it would have been a huge ruckus, because then integrating to find out the area would have been a questionable task. Okay, there would be a lot of questions actually. Then why should we take out the area and all? Anyways, the question is in our favor, so no problem. That means, guys, your 2a minus 1 less than equal to b less than equal to a square. So here, for a belongings to half to 1, b will belong to 2a minus 1 comma a square. Okay, so we have finished the definition, guys, and all. So we can finally write down what is capital R. So capital R is containing all those small a comma small b, such that For 0 less than equal to a less than equal to half, 0 will be less than equal to b less than equal to a square. And secondly, for half less than equal to a less than equal to 1, your 2a minus 1 will be less than equal to b and less than equal to a square. This is the complete definition of the region R. Okay. So what I can tell is, actually from here what we can tell is b equal to a square, which resembles y equal to x square, is the upper curve, and b is equal to 2a minus 1 resembling y is equal to 2x minus 1 is the lower curve. Okay, this would help us in finding out the area. So we have to find out the area of the region R, which I don't think is a difficult task right now. So a will be nothing but, first is integral 0 to half, and that will contain completely a square. So a square dA plus of integral half to 1, and this thing will contain upper curve minus lower curve. So basically a square minus of 2a minus 1, so minus 2a plus 1 dA. Okay, so a little bit of calculation, guys. Let's quickly do it. So this will come out to be, I guess, a cube by 3 in between your 0 to half, plus of this thing is your a minus 1 whole square, right? So a minus 1 whole cube by 3 in between half to 1. Okay, so guys, I'm not doing the calculation part. I hope you will do that. If you calculate, actually, this is very beautiful and symmetric. Both the areas will come out to be 1 by 24. Okay, if you calculate. Very symmetric, actually. If you could draw the curve, no need. It's pretty easy, so I'm not drawing out. Okay, if you draw the curve, it is pretty beautiful. So 1 by 24 plus 1 by 24, this would come out to be 1 by 12. So area A was given to be alpha by beta, which is equal to 1 by 12. So alpha is 1, beta is 12, and nonetheless we have to find out the value of alpha plus beta. So guys, your final answer for this particular question will come out to be 13. Okay. Anyways, that's the end for this question, guys. Really good question. Okay, like JEE Advanced has given piecewise. JEE Advanced loves to play with piecewise definitions. Piecewise definitions are like whichever good paper you take in, good, bad, whatever. Every year JEE Advanced paper you take in, you will always find one question on your piecewise definitions. Okay, you should like see JEE level maths is like that. You should know these small things. These will never come in your textbooks. You should know how to find. Okay, this particular question is an incorporation of about, I guess, 3 or 4 chapters. So that's massive, right? Like pure premium level JEE Advanced question. Okay. Anyways, guys, that's the end for today's video. If you have liked my channel, do like, share, and subscribe. Anything you want to ask, you may come out in the comment section, surely. And do join my Telegram discussion chat for fruitful discussions on your JEE prep. And that's it for that's it for today, guys. Keep studying, keep doing maths, and thanks for watching.